So I'm recording now. Yes, great. It's amazing to meet you guys. Welcome and good afternoon, good morning, good day, wherever you are, wherever you're coming from. This is the SheSat Ghana program. This is intended to empower women in Africa in satellite and space technology. And how can we empower women without our men around us? So if you're a man, a guy around, don't feel worried, don't feel out of place. You are welcome to our space, to our area. It's very great to see you guys. So so for this program, this is the satellite training workshop, and we are having it with collaboration with Xavier Space Solutions, Global Change Makers, and Space Locker. So yes, next slide, please. Oh yes, thank you. So these are the speakers. We have the Solomon Apeki, he's the founder of Xavier Space Solutions. And we have Daniela Santi, he's also part of Xavier Space Solutions. These two guys will be our speakers, and they will guide us through this journey of satellite engineering and technology. And our session moderators. And then we have the Space Local founder, Baptiste Fournier. He will also be a speaker for the session. And session moderators, yours truly, me. Hello, I'm Jemima Kwakui, and I'll just take you through this program as smoothly as possible. Another moderator, Jake Yorson. He is not currently available, but he'll be joining in as soon as he can. Yes, next slide, please. All right, so we are, as you're well aware of, if you're not, there's going to be a 2-day program. We'll take you to introduction to space and satellite technology today. Then tomorrow, you will go to the future of satellite technology from launch to space. There will be a hands-on session tomorrow, so get your hands prepared because they're going to be hands-on. Yes, next slide. Yes, so learning activities, you have a little introduction into CAD to design pocket heap structures. If you don't understand any words, don't worry, it will be explained throughout this entire session. And we have a Kahoot quiz. Kahoot quiz is basically an online quiz where you just join, give us your opinions, and they'll be displayed anonymously, obviously, for all of us, so don't worry about that. And group discussions. And if there's a need for me to create breakout rooms, that will be possible. So just be comfortable, just be relaxed, and have an amazing session. Next slide, please. Yes, so this was Xavier Space Solutions. So Xavier Space Solutions, we are the main proponents of this program. So we are basically a Ghanaian-based satellite technology company where we manufacture miniature satellites for the African continent and for our staff. Next slide, yes. Then these are our passionate team. So we come from a big variety of so many different things, so many different people. We have electrical engineers, PhDs. We have people from aviation and from aerospace. Then we have astrophysics and astronomy people from so many different backgrounds to ensure that the stuff that we do, they cater to both astronomy, astrophysics, and satellite and space technology. So these are our team. So rest assured, the products that we bring out are very good and with a very good background, a very good thoughts, a very well thought out of everything. Next slide. Yes, so what we do, you can visit our website at zavsat.space. They'll be shared in the chats later on. So basically, we are into satellite development and manufacturing. So custom built pocket cube development. So these are basically miniature satellites. Then payload integration. What do we want these pocket cubes to do? These are called basically payloads, which we put on satellite, send them to space. So basically, we are into satellite everything, testing and verification, validation, and we help to also, as we were talking about, climate change. Yes, these our satellites also help to detect these sort of things that affect it and how we can deal with it. Next slide. Yes, so our mission is these are to build space-ready satellites on the continent. You can see all of this and more on our website. So these are the kind of things that we build. Next slide. And our value is to empower Africans to reach for the stars. You could argue that so many countries are making satellites. So why should Africa make some? Because yes, we want to empower Africans to reach for the stars. No African left behind, no continent left behind, to ensure that we can push forward and bring Africa to the map. So we can also be part of these kind of conversations. Next slide. Yes, so our immediate goals to first complete our first high altitude test. So we finished designing our satellite. So first of all, we want to test its readiness in actual orbit, actual Earth's atmosphere. So we do that. So we continue to see all our subsystem in dirty environment. All of these things will be explained during the session, so don't worry. Then official pocket view unveiling and fundraising event next year, October 2026, like almost a year from now. So be ready. So join all our social media platforms, Instagram, websites, everything. All the links we put in the chats so that you can continue following our journey and be part of us. Yes, next slide. So these used to be our long-term goals, but now it's 2025. So it's like these are now our immediate goals, 2026 goals. So we want to fly our subsystems with Space Locker. That's a company. So Space Locker is a company helping us to test our pocket cubes and satellite that we've built. And we want to launch our pocket cube, ZavSat-1, into space. It's very exciting. We're very excited about this. So basically the mission for ZavSat-1 is for Earth temperature pressure profiling. So we have so many sensors on there that when they're in space, we basically get temperature, pressure to help us understand what's going on out there. So Jerry, we are talking about the climate change. We are working on it. You'll be fine. You'll be fine. Next slide. Yeah, so that is the end of just my session, my summary session. So I'll hand over to Solomon Ateki to take over this first module, this session. So thank you guys once again for joining. If you have any questions, please put them in the chat. They will be answered at the end of each module and each session. I hope you have a great time. So yeah, Solomon, yes, please take over.
All right, thank you so much, Jemima. And yeah, that was really wonderful. I'd like to say hi to everybody who has joined, and I know you guys are looking forward to a lot of things. I think from some of the things people have said in the chat, I guess it means we have people not necessarily from the space or satellite background. So we would try and make sure I think we can all find something useful to learn from today. So before we start, I would like to say that thank you so much actually for joining and keeping an eye out for activities like this, because I believe strongly this is very, very important in helping the continent, and which is why the section was open to people mainly from Africa to make sure we can get more people involved in space. So having said that, so I'm Apeka Solomon. I'm a PhD student at the University of Leeds in the UK. I'm actually working on something called quantum cascade lasers. You don't have to worry about what that is, but it's basically trying to build systems that you can use for satellite or advanced satellite communication. It also has application in imaging, among others. And I'll be happy to talk to you guys. Anybody who is interested in it, I think you can follow me on LinkedIn and we can chat from there. So yeah, let's get into today's section. All right, so for today's talk, so it's actually going to be in three different talks. The very first one is Introduction to Space and Satellite Technology. So I'll try and talk about what space is and a little bit about satellite also. And I think my other speakers or my other colleagues would talk about satellite and its application. And then I think we'll finish up with satellite networks and ground station. So let's get started. So this is more of an open question. So I'd like to ask, what comes into your mind when you hear the word space or satellite? You can put this in the chat and Jemima can tell me what people are saying. Or if you also want, you can unmute and tell me what comes into your head when you hear anything about space or satellite. So just a few minutes, and yeah, people can tell me what they think.
Yeah. So we're just waiting for people. Yes, great. We have two responses. So if I butcher your name, I am very sorry. We have Hadassah. She says that when I hear of space, I think of stars and planets. Oh, that's nice. Then Jerry says he thinks of galaxies.
Yeah, brilliant, brilliant. Any more? Yeah,
Um,
so I guess whilst we are waiting, I remember the first time, well, I think for me, whenever I hear anything space, the first thing that comes into my mind is aliens. That's what I think about when I hear space. Maybe for satellite, I think about something very complex, like a huge system that goes up into space. But yeah, pretty cool to hear what people think.
then we have Stephen Fatime. He says he thinks of space, regions of the universe outside the Earth's atmosphere.
Yeah, so you guys are all right in terms of I mean what people think about, and we will talk about what space is really in a bit. But I would like to talk about why we should actually care about space now. And the thing is, I mean, space is just well, again we will talk about this in a bit, but space is just um, it means a lot in different sense to different people. When you talk about what our culture has been, one of the examples I always like to say is, imagine you are the very first human being on Earth, and when you look up and you just look at the vastness of space, right? There are a lot of questions that actually come into your head. And these days, we know what a satellite is, which is an object that goes around a larger body, and it's very very interesting the way we sort of have a connection to these various things. But what I want you to really think about is when apart from all these connections we have with space, right, and things there. Um, we it's very very important because all space in general actually has a very very key impact in our daily lives, and these are some of the things well we would initially talk about. So, in terms of some of the things that space actually affect our lives, or even to be specific, in terms of satellite affect. So, we have things like GPS. So, the reason why, for example, you can move from place A to place B. So, maybe your friend invites you to a birthday party, you don't know where it is, but he can send you a Google location, or he can just send you a pin on WhatsApp if you use WhatsApp, and you can actually know exactly where your friend is, and you can meet them out and go out. And this is all due to space. And to be specific, something called GPS, which is the global position system, which helps us to map out different areas. And this is one key area about space that has on our lives. Another thing also that is very connected to our lives is the weather. So these days we are able to tell pretty much when it's going to rain, or when it's not going to rain, or try to understand if there's any potential impact of, let's say, a huge cyclone or something hitting our country or something like that. Now, these are all things that we are able to understand, right, these days. And it's all because of the fact that we started exploring space, and we have satellite out there that is able to track different clouds, and we can actually look back on the earth and see all these different patterns in terms of how these things affect the earth. And these are all things that obviously is connected to our lives. So for example, if you want to go out and um, maybe do something, sometimes you want to make sure you know if it's going to rain or not, so that you can carry an umbrella or not. And these are all things that I mean affect us, and these are all things related to space. Another important one, which is very very key, is communication. So with satellite, we are able to communicate and do a lot of things. So for example, the reason why we can actually even do this session in the first place is it's all because of satellite, and it has made possible applications like um, So Zoom and all those different platforms that all try to connect people from different countries to do things like what we are doing now, meet and talk about things that we are very interested in. And these are all things that I think you guys will all agree with me that is very, very, very important and connect people together. So for example, I don't know Jerry, but from this section, I can actually be able to talk to Jerry, ask him about um, what his country is like in terms of the temperature, the weather, and things like that. And it's all because of satellite. So you can actually see that it's very, very key in terms of every aspect of our lives, really. And one final one I would like to talk about, because I think a lot of us these days have this even on our phones, is the TV and the internet. The internet is really changing with the introduction of AI, among others, where we can be able to use the internet for a lot of things that we couldn't a couple of years ago. And this is all because of the fact of we having satellites in space, and it connects everything really. And without that, we can't actually do all these things. So you can have even your TVs where you can watch DSTV. People can broadcast different programs from different parts of the world, and we can still be able to watch it. It's all because of satellites and space in general. And this is one of the things I'm hoping highlights the significance of space and satellites. So at this point, hopefully it's been a good sort of idea of how satellites actually connect to our lives. So I want us to do something fun. So Jemima, if you could put the link to Kahoot, um, we can start that. So I have a couple of questions. I think it's just 3 questions, and I'd like us to try and answer them. So it's just true or false questions. So let me see if we can have the link there, and I can probably uh, stop sharing. Okay, yeah, so the link should be kahoot.it. If Jemima has it already in the chat. Yeah, you have that. I think that link takes you directly to the game and you can start, or you can just use the link I just also put in there. So let me start the quiz. So maybe stop sharing here and I'll go here and I'll do. Just give me a few minutes so I can share my screen and I can. So what's happening? Most like. Okay, so I think the
Yeah, I'm having, it says the game has ended. I don't know
okay.
how.
So I think what I need to do is I need to can you guys see my screen?
Yes, yes, we can.
Yeah, so go to yeah, I think if you go to kahoot.it and you type in this code, this pin, yeah, it should take you guys hopefully to the actual game now.
Mhm. Which what should we? Okay, okay, got it. Okay. Oh
I
yes,
think
so
the thing
yeah.
is I'm actually sharing the wrong thing. I should be sharing this screen, sorry.
I,
So it's waiting for players. Yeah, I think this should be this one. Yeah. Yeah. All right, so go there and then start. Yes.
yes, we're
Okay.
in.
Maybe I should go back. People join already? Okay. Are people in or people are struggling to join? Remember, can people join?
Sorry about that. I was muted. One person in the chat is having difficulties. I've reposted the link.
You know
So it
what?
will open
Yeah, yeah. Let me generate a different link because I think
this particular link work. The old one, oh, okay, yes. The game has ended, yes.
yeah. So
So
let's just use a different link.
yeah, I think whenever you leave and then you come back, it has ended. So yeah.
Sorry about that. Let me wait for a lot of people to join, then I can start it. Okay.
Okay. Yeah. Okay, so that's the new. Okay, so there's a new link in the chat. Let's just click on that.
Yes. Yes. So we have aerospace.
Yes.
Good. 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 Yes. We have Sky. Jeremy also there. Good. We
So
have Ben also. Boche also in there. That's some pretty cool emojis people have beside their names. Oh, I like the Boris one.
yeah.
Oh, nice. Right. So actually, there's going to be a winner. So if you try hard, I think you would. We can actually get a winner there. Probably we can get the person an X-Base souvenir or something. Yeah, let's see.
Exciting.
Okay. Okay, so Solas Papai has raised a hand. Do you want to say something, Solas?
Hello.
You.
I think I've entered, but my name was not mentioned. Please, am I there? Oh, that's not it.
What name did you enter with?
So Lisabi.
Oh yeah, I think you're in there.
Mm-hmm.
Wait, let me see. Yeah. So
Please, how can I do
yes.
So
that?
let's we
Should I,
see you.
should I click on the link again? Or
Oh no,
Oh
you're
no, we
already
see.
in. You're in, so don't worry. So when the questions start, you can see it, and then you just have to respond to what answer you think it is. Should we start?
Okay, yes, I think so. I think we can start.
Yeah,
We
just
have
give 1 more minute to see if other people can join. Yeah.
yes. Exciting.
Yeah, because we have 33 people in here, and we just have about not a lot of people. Yeah, we have about 16 people, so we still have a lot of other people who can join. So yeah, if you really want to join, I think you should try now before we start. Okay, I think let's give it a go.
Yeah, let's give it a go.
The thing is, we don't have a lot of well, you know what? Let me just wait 1 more minute. So this is the last call. Last
Yes.
call. All right, here we go. Let's start.
Yay.
Okay. So satellites are only used for spying, true or false. And we have
Is true the diamond and false is the triangle?
yes.
Okay.
So blue and then red. So
Yes.
countdown 5, 4, 3, 2, 1, and then it's gone. Good. So just one person didn't get here right. That's nice. That's actually like 15 people. I mean, it's nice that 15 people got it right. All right, so let's go to the next question. So on the scoreboard, we have Hadas leading, and we have Boris in second place, and we have is it Mumi? And then Sky and Taco also following up. So let's see who wins it. So the next question. We have only explored a tiny fraction of our solar system, true or false. Game countdown going on. Let's see who is going to win. Okay, so 5, 4, 3, 2, 1, and great! Much better than before, I guess. 16 people got it right. and only 3 people didn't get it right. Now let's see who is leading now. Okay, so we still have Hadas in the lead, and Sky following. It's pretty much the same top 4 in there.
Yeah.
Now let's go to the last question and see if there's going to be any change in there. So space is completely silent, true or false? True or false? So let's see. Okay. So 5, 4, 3, 2, 1. Okay. Okay. So that was a bit that's interesting actually. So 13 people got it right and almost the same. I mean half of those people actually um didn't think space is actually completely silent. Anyway, yeah, the correct answer is that it's actually silent, and the reason is because there's no air in space, which means that there's no medium to actually be able to transmit the sound. So great. Now let's see who the winner is. Oh, so after being in first place for both
Yay.
2 rounds, um, Mumi was able to win, and that's
Shaitan,
actually
please, I
really
can't hear.
nice.
Sorry for talking whilst you are talking, but I can't hear anything. I don't know if you can hear me.
Yes, we can
Um,
hear you. Can everybody else hear me too?
yes, we can.
So I guess whoever has issues, maybe I think sometimes what happens if you can't hear, maybe you can increase your volume and see if it helps. If not, you can just leave the meeting and come back in. Sometimes it just fixes itself that way, but you can try that way and let's see. But yeah, that was great. That was actually interesting. And I think we would be learning a bit more about some of these questions in a
Yeah.
few minutes. But yeah, thank you so much for playing. And if we can get back to uh, the session, yeah, just give me a few minutes to bring the slide up again, and we can
Oh,
continue. Okay, all right. So hopefully that was fun. I'll try and go over the questions so that people can understand. So the very first one is satellites are only used for spying. So this is actually not true. Satellites have a lot of applications. So for example, satellite is used for um, studying the earth to be able to understand, for example, weather patterns, which is very, very useful for climate modeling, among others. Satellites can also do different things. For example, there are lots of crazy things people are doing with satellite these days. For example, they can put robotic structures on satellites to be able to maybe grab an asteroid or a rock from space and things like that. So satellites have a lot of different applications, and it's not just used for spying. So the next question was, we have only explored a tiny fraction of our solar system. Is this true or false? So this is also true. The thing is, our solar system is very vast. We have 8 planets, and so far the only, I would say, object in space that we actually know a lot about and have even been able to go to is our own moon, right? And that is just one object among the, if you're talking about planets, among the other 7 planets, and even including other objects like dwarf planets, which we are still exploring. So it's just a little of our solar system that we know, and there's a lot more that we are still learning. Yeah. And then the final one is space is completely silent, and that is actually true. Like I was saying a few minutes ago, it's because for sound to be able to travel, it means that there should be a medium, and those medium, as we have learned, or those medium, an example is you need air to be able to carry sound through. You need sometimes even in solids, you can be able to transmit sound waves, and without those different mediums, space is completely silent because there's nothing that can carry these waves off. So that was a little sort of fun and tested our knowledge of what we know about space. So let's move on. So what do you want to discover about space and satellite? So at the beginning of this talk, like I said, it's we are going to cover a few basics about what space and satellite are. But I would just like to know if there's anything specific that people want to know about space or about satellite. If it's just what space is and satellite, that's also good enough. But if can we spend like 1 or 2 minutes just putting in the chat some of the things about space and satellite that we want to learn. For me, I think personally, maybe I can start and say, for me, I'm very interested in building satellites, and I also want to go to the planet Mars one day, and those are some of the things I want to do, or in some sense, discover or explore about space and satellite. So, anybody else in terms of anything that they want to learn? Yeah, so I can read it out loud so that it makes it a bit easier. So Jemima says he wants to know more about space exploration, which planets humans can live on. That's great and very interesting. Jerry also wants to know, I don't know if it's a direct question or one of the things you want to know. Okay, I guess it's one of the things you want to know, which is um, why satellites stay in orbit. Great. So we actually have a slide of this, how satellites are able to stay in orbit, and we talk about it. So that's nice. For Ben Yoli, he say, as for me, I want to know more about planets Jupiter and Saturn. So that's more astronomy, but that's pretty interesting to know. Um, Hadassah, well, before Hadassah, Amira also says, I want to know if aliens exist. I think it's an age-old question that a lot of people want to know about. That's also a good one. Hadassah also says, I'm interested in the assembly and programming of parts and how much it costs and where that kind of money comes from. That's actually very interesting. Yeah, so those are pretty cool things people want to know about, and yeah, I think some of those things will be answered in the session. So let's look out for that. So I'll take more. I mean, one more, and then we can continue. So I want to know more about orbital mechanics and satellite communication. That's pretty detailed, Stephen. Yeah, I think hopefully we will touch on some of those things in a bit. And then Caroline says, I want to know more about space so I can execute my sending a human, yeah, a humanoid to spy. Oh, that's interesting. That's interesting, Caroline. And then Solis says, is it right or wrong to use satellites to watch people or collect their data? I think it's one of the things we can all, I mean, once we learn about satellite, I think we can all have our own opinion on what that is. And then Evans is saying, I want to know more about building a satellite ground station infrastructure to support space activities. That's also a good one. Daniel says, I want to know more about satellite building. Pretty cool. And then Anna says, I'm interested in satellite, especially the sustainability of the heat of the sun. Very interesting one too. And Daniel Santos says, I want to discover the beginning of the universe. That's also very, very ambitious and a very, very good one too. So let's get back to our slides. So yeah, so having had all those interesting questions and things people want to do, talk about what space exactly is, because there are lots of things. I mean, apart from the fact that we know everything up there is space, people can define it differently, and there's a standard definition of that. So let's look at that. So basically, if you talk about space, it's sometimes debatable in some sense, and people say that maybe there's a line that when you go beyond, then you can actually say that you're actually in space, and actually there's some truth in some sense. So there's the very popular Kama line, and that is roughly 100 kilometers above sea level, and if you pass this line, people generally will say that yes, you are in space, right? And that's that definition is there in the sense of, so we have different layers of the atmosphere. So for example, we have the stratosphere, we have the troposphere. Actually, the first one we have is the troposphere, followed by the stratosphere, the mesosphere, and then the thermosphere. And the stratosphere, I'm sure people have heard a lot because that's where we have aeroplanes traveling, and that roughly would extend into the mesosphere a little bit, which is about 50 miles in distance. And that distance, roughly, the moment you get into the you pass the mesosphere, then you are sort of getting into space, which you get close to in terms of kilometers, around 100 kilometers. And that's sort of the boundary that people push, or people usually use if they want to say they are there in space. So I don't know if recently, so you will hear that some billionaires have gone to space, and it doesn't mean they went to, for example, they went to the moon or something. The moment you pass that limit or imaginary line in some sense, then we can say that you are in space. And there are different ways you can get there, which we would cover. But that's just to talk about doing things in space or in terms of the boundary. And one thing we have already talked about is because there's no air in space, then it basically means that there's just vacuum, right? So it's just empty space with a few particles, and some of these particles come from um, the the sun, for example. So ionized particles, for example, there. We also know that in terms of space, we have huge objects like planets. We have asteroids, which are little rocks of ice and dust. We have comets, which are also made up of ice mostly. And these are all things that we find in space. But in between these things, it's basically just a vacuum. Also talking about what it looks like in space, the temperatures can be very, very extreme in terms of, so if you go outside, far away from, it means you are going away from the sun, which means that you have less heat, which means it can be extremely cold. So for example, planets like, dwarf planets like Ceres and Pluto, they are very, very, very cold. So we are talking about minus 100 degrees plus in temperature. And it can really be like that. And also in terms of the plus side, so the closer you get to the sun, the more extreme the temperatures get. And an example is if you are just if even given the location of the planet Earth, if we were a little bit closer to the sun, we wouldn't have liquid water around it, which means that life as we know it would not be possible in the first place. And this is in terms of that. I can even relate this to some of the satellite missions that Xavier Space Solutions will be undertaking. One of the things we'll be looking at is measuring the temperature of space in general and stuff like that. But that's just to give you. And in terms of temperature, also relating this to radiation, because the sun emits a lot of radiations which can be found in the EM spectrum, which is the electromagnetic spectrum. Again, you don't have to worry, it's just a family of radiation. And the sun, among other objects in space, can emit these high levels of radiation. And those are all things that we do actually find in space. So why do we go to space? I've talked about a few reasons in terms of, in general, why space is important and why we study, we study space. But it's you can actually look at it from various viewpoints. And one of the viewpoints I usually talk about a lot is, so if you have read about when the Apollo mission started, right? And if you don't know about the Apollo mission, it was just a mission where the United States of America then, around the 1960s, decided to go to space. They decided to go to the moon and explore and do all those different things. And the idea of wanting to go to space led to a lot of different companies. So for example, there were a lot more electronics companies starting because people needed to manufacture different equipment that eventually will go into building a rocket or building a spacecraft. And these are very, very, very key things that one, it meant that the economy had to grow, which meant that there were more jobs for people to work in the electronics industry, for example, and even in terms of their general arts and stuff like that. Those fields also had to develop because we needed people to serve as representatives of these space agencies to talk to people about why we want to go to space, or we are even interested in going to space. So the reason why we actually want to go to space is it's not just in terms of the different benefits we have already talked about, but it serves as an inspiration for human beings to want to do more, to know more about our immediate environment. For example, our solar system, and it's very, very interesting um, in this sense. Of course, we can talk about the different reasons, and that's what we are going to talk about, the different reasons in terms of scientific application, and that's what I'll talk about now. So, in terms of scientific discovery, there are lots of things that we want to know. So, for example, we want to know what our moon, which is our natural satellite, is made up of. We want to be able to understand the planets around us. So, for example, the closest planets to Earth is the planet Mars, and we want to know if, for example, it had been able to support life in the past. And these are all things that um, pushes us to actually to go to space. There are a lot of other things that I think a few people have mentioned in the group chat already. They want to know more about stars. The people are interested in knowing how the universe even started in the first place. And we can actually learn about all those things by going to space in some sense. So we can send telescopes, space telescopes. We can send satellite that will be able to take wonderful images, or even go outside the solar system to take images of the galaxies, which contributes to our understanding of how the universe started, right? And these are all very, very interesting reasons why we actually go to space. We can also look at some of the things we were talking about at the beginning, which is understanding the Earth's climate and how it affects our lives, and how we can be able to live sustainably on the Earth. And these are all things that are our motivations. In terms of technology, like I said a few minutes ago, having to want to go to space had to, I mean, push other fields. So people had to start developing new electronic boards, new ICs that are very small that can fit in spacecraft, and things like that. And those were very, very important. I can give you a good example of that. So, for example, Wi-Fi that we have these days that we can connect and use internet were all spin-offs from having to want to explore space, right? And people had to think about, oh, how can we be able to send signals across various distances, right? And it led to Wi-Fi in this example, like I was talking about. And there are other different examples, like the MRI machines, which were initially something we were trying to use to look at distance planets and stuff. And then we realized actually we can use that in the biological sciences to be able to understand the human body and things like that. And these are all things that space actually enabled these things to be possible, which, if you ask me, is very, very interesting. There are a lot of other reasons, which again, I've touched on a little bit. So in terms of the commercial aspect, because of space, we can actually develop several other areas which are not necessarily space. So for example, tourism in general, before what we knew about was tourism is more on the earth, where you can go to different places, see how things are. These days, we have billionaires being able to go to space and look at space. And those are all different economic opportunities that space is actually bringing. There are lots of new job markets, which I'll talk about. For example, people having to want to mine asteroids. So those are rocks in space, and people think it can actually get some precious metals or minerals from it and use it. And these are all different opportunities or new market that is emerging because of space. In terms of global security, we have sort of started talking about it when people were asking if it's um, uh, is it ethical to use satellite to spy on other people and stuff. And it's just one of the, if you ask me, in my opinion, one of the wrong applications of satellite because um, initially, with the idea of having satellite, we wanted to use it to study the earth and to be able to understand it so that we can be able to see how we can improve the way we live. But of course, we can use it for different applications. But in terms of global security, with satellites, we can actually be able to monitor if people are doing things right or not. So, for example, if you're not supposed to build a nuclear weapon and you're building it with satellite in space, we can be able to use that and see that. And of course, I know it's a very, very difficult conversation to have or discussion because it means different things in different parts of the world, but it helps us in global security and inspiration and human spirit, which is what I talked about at the beginning. Just we wanting to go to space and do more means a lot to us. And because of that, for example, let's say Jerry, that's one of the names I remember, and Soles, those are people that I don't know directly, but we all share the idea of wanting to know more about space. And because of that, I could work with Jerry and Solis and probably Anna or somebody else to build a spacecraft in the future, which we can take to, let's say, the planet Mars. And those are all, I mean, the human spirit of wanting to explore, wanting to explore, wanting to understand what our place in the universe is, and it's very very important because it motivates us to do more, to build systems, to be better people, and all those things. And those are all the spirits that space actually tends to bring. And in general, having said that, we can actually look at the the idea that we satellite in general is what we use for looking back on Earth and being able to monitor it. So some people will say they are our eyes and ears in orbit, and in orbits here means in space in some sense. So the question that somebody asked at the beginning, what how do satellites actually be able to are able to stay up in space. Before I talk about that, I'll just look at talking about what satellites are in general. So I've sort of hinted to that when I mentioned that satellites are objects that would go around a bigger object. So if you can think of, let's say this is my hand and there's the bigger object, hopefully you can see, and there's a small object here going around my hand, then this small object becomes a satellite. And one of those objects that we know is the moon. So the moon is the Earth's natural satellite, and we decided to call it the moon. But if you want to always understand, or the first thing you want to think about when you look at, or you look at what a satellite is, then you think about the moon. So how do they stay up? So what we know is this. So for example, the moon, it's actually moving around the Earth, and it's actually moving at a specific speed, which I don't know from the top of my head. But what happens is because that speed that it's moving is at a specific distance to the Earth, there's a force that actually pulls the in this case the moon towards the center of the Earth. And because it's moving at the same time and that force being applied, it almost seems as if the moon is falling constantly to the Earth. But because it's actually moving at the same time, it doesn't just fall and then just drop on the surface of the Earth, but moving and then falling. That whole process keeps the satellite or the moon in its orbit, which is just the path that it follows around the Earth. And this is the main reason why it's able to stay in there. There are different objects that you can, or there are several examples you can think about. So if you can, I don't know if people have done this before, but if you tie a string to a ball and then you sort of move around, sorry, or you just wind, you notice that the ball would be moving, and it doesn't seem to come there, and just because of the fact that it's it's in a similar scenario where it's going around the midpoint, which is where you are moving around, and that's what tends to make it stay up. And if this is not clear, you can say in the chat, and I'll try and give different examples of how these satellites or yeah, these satellites stay in orbit. So from that same idea, human beings, we decided to build these our own satellites that we put into space to do different things, like I've mentioned already. And we are going to talk about some of them in a few minutes. So having talked about orbits, so again, I'll highlight what an orbit is. So an orbit is just the path that a satellite will take around a specific object. So if I want to talk about the moon, so the moon's orbit around the Earth would be a big line that goes around the Earth. But these different orbits, because of its relative position to the Earth, we have different names that we give to it. So we have three main ones. So we have what we call the low Earth orbit, and this will be the closest orbit to the Earth, right? And then we have the medium Earth orbits, which would be, as the name suggests, just not far away from this from the Earth, that we call it the medium orbit. And then we have the, so this key should actually not be right. We have the other one, which is called the geostationary orbit, and those are the orbits that is just on top. So if you look at the polar regions of the Earth, so just somewhere there, just on top of the North Pole, that orbit is called the geostationary orbit, and it's one of the very stable orbits that we put things in to be able to look at different things. Most of the time for satellites or small satellites, which is the concentration of this section, it's usually put into a low Earth orbit, so not so far away, very close to the Earth, and it's able to do the different things we would all talk about. So having not done a lot of rocket science or blowing our mind about how satellites, for example, get into orbit, let's get into that now and look at how satellites are able to get into space, or how we are able to put them in there. So just a little rocket science. So one of the main challenges of, or before we can get a satellite into space, is overcoming something that is called gravity. So I'm hoping that we all know what gravity is, and it's just a force that keeps us grounded on the surface of the Earth. So, for example, if you have this phone, when I drop this phone, it actually doesn't stay in the air or float, because there's a force that tends to bring the phone towards the center of the Earth, or bring the phone to the ground, and that's what we call gravity. And I think we all know that Newton is the very first person who brought up that idea in terms of what is able to happen. So with the same thing, what that means is whatever object you have, the natural decision, or if I should put it, of the object is it always wants to drop to the surface of the Earth. So if you want to take it to, I mean, if you want to take it up into space, it means you have to push it, you have to do something to get it into space. And that is rockets, and they work on a very, very simple principle. And the very principle is that to every action, there's an equal and opposite reaction. So if you push something hard, I mean, against something very, very hard, you'd have the same reaction um, in the opposite direction. And that's how we are able to get rockets, or not just rockets, but so we usually will put the satellite or whatever we want to take into space on top of the rocket, and and then we can take it into space, and there are different things that happen to it. But the main idea is, so for rockets, they would expel a lot of hot gases, which is that um, which is that force I'm talking about. So as it expels that hot gas downwards, it tends to have an opposite reaction, which pushes the rocket up because this force is going this way. It just pushes it up, and that is how we are able to overcome that um, challenge of overcoming gravity. And the moment you're able to overcome gravity in that sense, then you can get your rocket high up into space. And when it gets there, there are different things that happen to it. So there's what we call the multi-stage process. And those are all processes that is part of the design of a rocket. So there's the part that just has the fuel, which is what burns to give you that lift off. And once you get into, so remember we talked about the different boundaries. So the moment it passes the Kama line and it's in space, then you can have the other part of the rocket separate and fall back to the earth, and then the other part will sort of start floating really. And we design it in that sense to be able to make sure we don't just send rockets, not the entire rocket, but the part that has the fuel that can be harmful um, to space. And that's one part. Another part which we have sort of talked about is the propulsion. The propulsion is basically the engine, which is able to burn whatever fuel you have and then get your rocket into space. And there are different things like where you actually do this, where do you put your rocket? Those are all things we call land sites. And we would have a good discussion about this later tomorrow when our guest speaker talks about what happens when you get your satellites to their launch facility and stuff like that. But hopefully this gives you some sort of idea on how satellites, sorry, on how satellites get into space and the things that is involved. Again, this is supposed to provide an overview of how all these different things happen, but hopefully it's useful. So what's next for space? So we have talked about a lot of different things. What are some of the crazy things? What are some of the interesting things? What are some of the exciting things people are doing in space now? One of my personal favorites is what we call asteroid mining, right? So people want to, well, before we talk about those and all, so people actually want to go to space and start mining um, asteroids. So asteroids are made up of dust, ice, and some rock constituents also. And some of these materials or rocks or things are not things we have on Earth. So they have ideas of being able to sell this. And it's one of the trending things. You have a lot of people, like there are a lot of companies who are looking to do those. But apart from that, in terms of the general view of what the space sector has been like worldwide, the main thing that is happening or is going to happen over the next few months and years is, so it's been more than a decade now that we have not had a human being actually on the moon. So the Apollo mission put the very first man on the moon. And after that, we had what we call the International Space Station, which is the ISS. And that is basically a huge satellite that human beings can live in. And it just hovers around the Earth. And that's where a lot of people or a lot of astronauts. So if you hear that an astronaut has gone to space, that is where they go. They don't go to the moon or anything anywhere else. And what NASA is doing is that with its program called the Artemis mission, it wants to put human beings back onto the moon. And that's one of the things that is exciting a lot of people in space now. And what they want to do is they want to make sure there's a moon base where human beings can actually go there. And then the next step would be to go to Mars, which is my favorite planet. And a lot of people, not just NASA, but SpaceX is looking at building huge rockets that can take people into into further into space, in this sense, going to a different planet, which will be the very first time that anything like that has ever happened. And Of course, we also spoke about this some minutes ago, in terms of space tourism, where these days, if you're rich enough, you can actually pay to go to space, right? And these are all the sort of the current trends or what is next for space that people are actually doing. There's also this idea of having a lot of satellites in space to be able to talk to each other. And if you do that, we call it a constellation. And what happens is if you can get different satellites to talk to each other, you can actually use that for a lot of applications. And one of those applications is called IoT or Internet of Things. And with that, you can provide internet. So if you have heard of Starlink in Africa, it uses a lot of these satellites to talk to themselves, and they can use that to provide internet in remote areas, for example, in Africa and among other places on the earth. And that's one of the major things. And of course, we can talk about this if people have questions. I've already talked about asteroid mining, so we'll move on into advancement in something called propulsion. So propulsion is basically what pushes something, right? So in terms of space, we have propulsion system for satellites to be able to help the satellites move once they are in space to stabilize them. We have propulsion systems for rockets, among others. And there's a lot of um, research in this area to make sure that we have more advanced systems that are more stable, that are more sustainable, and things like that. I think this should end the very first part of the talk and then my talk. Please let me know if you have any questions. You can put this in the chat or you can unmute. So I'll stop talking now and take any questions if anybody has any.
All right, that was an amazing session. Thank you, Solomon. I'm sure we learned a lot. I mean, I sure did. And if there are any questions, you can just put it in the chat. Okay, one person asked a question. Anna is asking that, please, who owns the satellite? So I don't know which one, but probably she means the one where the people are in space and orbiting. Yes, I think was what she means.
Yeah, I mean, I can talk a little bit about it in general. So Anna, so if you are able to build a satellite, then you own it. So, for example, we have Nigeria has launched a few satellites in the past. So it would mean that Nigeria owns it. And for example, Ghana has launched a satellite. It means Ghanaians built it and then they sent it to space. But these days, private companies can also build their own satellite and sell them. So you can buy the satellite if you want, and it will belong to you. So to simply put it, they are different. Depending on who builds it, then you own the satellite. And these days, you can actually satellites are cheap, and I'll say cheap in quote, and so much that people can actually be able to buy it. I'll probably just go on to the next question. Can we get a recording? Yes. So the section has been recorded and it will be shared with everybody. So yeah. Okay. Yeah. Jemima, do you want to take the question, so I should just go ahead? Maybe it's much
Which would
quicker.
you be more comfortable with?
Maybe it's much quicker. Yeah. So Jerry is asking, can you tell me more about the ISS? It's a satellite co-owned by different countries, right? Yes. So that the ISS is for the International Space Station. Initially, I think it was built together with with Russia, the United States. I think even the Chinese these days have also contributed to building it. So it's a place where human beings or astronauts can actually go there, conduct different experiments. So there's microgravity experiment that they perform on different things that we are interested in. And every now and then you have people or astronauts from different countries going there to stay there for a long time or a short time and perform different experiments. So that's just to give you an overview of what the ISS is. Someone says, please, are there regulations as to how many satellites we can have around the Earth? What effect would a large constellation have on us? So that's a very, very, very good question. So the so there are regulations, and it's usually by what we call UNOSA, which is the United Nations Office for Outer Space Affairs, right? And they sort of have regulations on what you can do and what you can't do. At the moment, I don't think there's a regulation on how many constellations you can have, right? And that's why people like Elon Musk can send thousands of these satellites into space without actually having to really worry about it. Now, there are a lot of effects that these constellations can have. Um, More of it has to do with the research we do. So, for example, if you imagine you're having a lot of satellites in the Earth, that it covers the Earth like that, right? What's going to happen is people like astronomers who point telescopes to space and then observe objects in space. It means you will not be able to see anything because there'll be just a mesh of satellites there every now and then, right? But it's not going to happen because space is pretty vast and you can't have satellites unless we get to a crazy world where there are lots of billions of these satellites in space. Yes, then it can cause something like a mesh, which will make it difficult to do observations and stuff. So in terms of the effect on research, that's what it is. In terms of research, instead of the effect it has on human beings, I can only tell you some of the good effects. I don't know of any of the bad effects, if we have anything like bad effects. But what I mean to say is that, so if you have a lot of these large constellations, it means that internet is going to be very cheap, right? Because if you can use satellites to do these internet, it means those other people who use large satellites for internet, well, to provide internet, would have to reduce their cost. So it means internet um, prices would go down, which is a good effect on us. In terms of the maybe bad effect that it will have on human beings, I can't think of any because these satellites will be in space. I can only say that the more satellites we have, the better it is. But like I said, in terms of research, these satellites will also, maybe one of the not good effects would be to say that, so if you have a lot of these satellites in space, it means they will compete with the frequencies at which people do different research or send different signals. So to get to a time that all the band for communicating for satellites will be so packed up that there will be no
Yeah.
space for other satellites to actually be able to use for their communication, right? Maybe you have to turn your satellite off when somebody else is transmitting and then you turn back off. So, which I think will be complex. But yeah, if you get to a place where we have large constellations, I think that's one of the effects. And then Solis is asking, please, a mineral like gold can be used for jewelry. Can we use asteroid for, or I guess you're asking what we can use asteroid for. Yeah, I mean, I would buy a chain which is made up of an asteroid. I would buy because I'm a space person, but yeah. So um, people seem to suggest that they are different. So there are a lot of elements. I don't know some of their names, right, really, but they have unique element that we don't have some of them on the earth. So yes, you can use it for anything, and people can use it for different things. People even think you can use it to generate energy and stuff, but I don't know about that. But yeah, please, who invented it? Can you? Oh, okay, I guess you are asking about the International Space Station. I guess. Yeah, Anna, if you can clarify that, will be good. Let me see. Oh, who owns the satellite? Who invented it? Yeah, so I don't know the first person to have built a satellite or invented it. I don't know, but yeah, I can look it up and let you know. And Peter is asking, please, can we get a recording? Yes, I think we talked about that. Can you tell me more? Okay, am I reading the same questions? Yeah, I am. Silly me. Can a satellite crash into another satellite? So yes, it's possible, but usually it's not likely because all the satellites have their own path, which we call the orbit that they travel in. So if this one is here, this one is there. So they don't tend to crash really, but it's possible. How many times does it take a satellite to orbit the Earth? So again, it depends on what kind of satellite, right? Um, if the satellite is in low Earth orbit, we call it the satellite latency. Um, or something. And what it is it's just the time it takes for the satellite to go. Some satellites have a day. It takes them a day to go around. Some of them in it depends again if it's in low Earth orbit or medium Earth orbit or the geostationary orbit, right? Some of them depending on their speed and also exactly what orbit. Because even for the low Earth orbit, it's between 500 kilometers to about, I think, 700 kilometers or so. And the further away, I mean, the region, yeah, it will depend. So I would say it takes maybe between 30 to a couple of hours. That's the time it takes usually for different satellites to be able to go around the Earth. The Chinese now have their own private space stations. So we currently just have two, the ISS and the Chinese. Yes, it's true. Yeah, it's one of the things I wanted to add up to that. But yes, that's it. So yeah, I think those are pretty good questions. And hopefully you guys enjoyed the talk. I think we can, if there are no questions, I think we can move on to the next question. Um, yeah, thank you so much.
Yes, thank you very much, Solomon, for this amazing session. From all the questions and the engagement and everything in the chat, we can see that you kept everybody engaged. We were very excited for this session. So we are now moving on to our second session, which will be led by Daniel Asante. So Daniel, are you ready?
Yep.
All right, Daniel,
I
so
didn't.
we can hear you.
Yeah.
And also, do you want to share your screen with a slide, or you want me to go through and you tell me to do next slide?
uh, can you hear me now, though?
No, it's very faint. We can't really hear you.
Hmm. Because I
Better
can
now.
switch
Maybe you just have to speak a bit louder. I don't know. We can hear you, but yeah.
because I don't have my headphones on. So, but if I switch to my headphones, I
Yeah,
can't.
yeah, I think we can hear you. Actually, maybe you just have to go close to your PC and then yeah, just talk a bit louder.
Like you can hear me like this.
Yeah, yeah, this is brilliant. Yeah, we can hear you.
Yes.
Oh, okay.
So do
Oh,
you want to share your screen or I should just move the slide for you?
I think better I should so that in case you need to
Yeah,
go
yeah,
somewhere,
brilliant. Yeah, yeah, yeah. Cool.
I can go. Okay. Is it in a presentation mode, general, or is it? Okay.
Yes,
Okay.
yes, yes, it is.
Yes. Yes, it is. Sorry.
Okay. Hi everyone. My name is Daniel Sante. I'm currently a mechanical engineering student in Canada, and in next space, I mostly deal with the mechanical design of all of the like, pocket cubes that or that we are trying to develop. So for today, I'll be talking about satellites. I'll try to rush because I need to leave somewhere in a couple of minutes. So I'll try and use like 20 to 30 minutes max to cover all these. So Solomon previously spoke about, satellites, but he was mostly talking about, like the conventional satellites, the big ones, that cost like millions and millions of dollars. But here we're going to be talking about miniature satellites and some of their applications. So as we all know, or as we are about to know, space is now being accessible to everyone and anywhere in the world because now there's been recent developments in miniature satellites, um, such that there's been a process or innovations in terms of propulsion, onboard computing, and communication systems, such that we have been able to shrink all these bigger size components into very small things. So now we can use smaller satellites to still do complex missions. We're going to talk about some of these small satellites and how they're able to act in space, and also what kind of complex missions they are able to achieve. So this is just an overview of the satellites in general, from big to small. So we have like mini satellites, which have mass of like 100 kilograms to 500 kilograms, and they're like, really huge. Like you need to have like a warehouse to make such a satellite, and a whole team of expertise from all around the world. And slowly it kept on decreasing to microsatellites, which were from 10 to 100, nanosatellites, which are from 1 to 10. And for space, we are into picosatellites, which is basically from 100 grams to 1 kilograms. And also we have even smaller satellites, such as the femto satellites, which are even less than 100 grams. Since in X space, we mostly deal with pocket cubes. Here is an example of, if you look at the model here, this is from Xavier Space Solutions. Like this is our recent pocket cube, and you can see it has antennas, it has a structure and some switches. But in general, what this slide is supposed to show is the size, right? So I'm sure we all know what a Rubik cube looks like. So if you, as yes, Solomon is showing one Rubik cube there. If you look at his video, so literally a pocket cube is literally the size of a Rubik cube, and he has the card model, but the physical component that we built, he's holding it. It's not too bright, but I think you can see the shiny metal.
Sorry. Yeah.
It's fine, yeah. So that's the like comparison. Like it's really really small. So that's what like is we are basically saying, like trying to show how these bigger satellites, because of innovation and technology, we're able to make them really small, and they can still do a lot of complex missions. And on the right, you can see the avionic boards, which are inside what he's showing. We have the power board, the OBC, and the payload uh, board. So this bit I'm fascinated by how what is this?
Yeah,
I wanted
maybe you can take the questions at the end.
later, yeah, okay.
Yeah.
Um, so yeah, like it does the comparison of the pocket cube in relation to a Rubik cube, so you have a much more detailed idea of the size of these things. Literally fit into your palm. Next slide. Now, speaking of pocket cubes, right? Before pocket cubes came into existence, in terms of smaller satellites, we had something called the CubeSat. So the CubeSat measures, imagine a box that is measured 10 centimeters in length, 10 centimeters in width, and 10 centimeters in height. So that's what, in general, like everyone in the world was using. Mostly it was CubeSats, and that was developed by a university in the US. That I think it was University of California or Polytechnic, one of those universities like that, and they developed the standard. So here we are just trying to also compare a pocket cube to a single CubeSat. Since one pocket cube measures 5 centimeters in length, 5 centimeters in width, and 5 centimeters in height, eight of these pocket cubes or will fit into one of these one inch. So it just gives you a further idea of how small a pocket cube is. Pocket cubes are the future. Here we are seeing so there's a company called Alba Orbital, and they make the mechanical infrastructure or systems to launch these small pocket cubes to space. And they have also developed like some pocket cubes that we are seeing in the image here, and here we are just going to discuss the applications of these pocket cubes, in the sense that they can be used in Earth observation, no matter how small they are. They can be used for technology demonstration of like new systems that you want to test in space. You can also test your amateur video communication, and also Internet of Things, like for internet connectivity, or if you want to just send data through your temperature sensor or your yeah, those IoT devices. Here are some photos of the Earth I was taken by a pocket cube. So this just shows the advancements that like even these small things, these small satellites can take really good images in space, and this is just the beginning, right? So already they're able to take clear images from space, and that was taken from the Unicorn satellite. I think is the one here in the middle. It was taken by this pocket cube. And this pocket cube is able to take photos like this. So imagine well like what's going to happen next. Like you can just place like a radar there and do more detailed analysis of the earth. So it just shows you that now everything is so accessible, and no matter how small the satellites are, we're able to do a lot of complex analysis in space. Now, when working with satellites, we have something called a flat sat. So as Solomon showed you, right? You saw the pocket cube, right? It has boards stacked on top of each other and things like that. But this way, right, it's already compacted and it's ready to launch into space. But when you are actually building a satellite, we have something called a flat sat, and that's what helps you test your system. So it's essentially a working satellite, but on a table, right? So you have your power cord here, you have your onboard computer, you have your payload, which can be your camera or or like a sound recorder or anything, right? All you need to do is just place them on the table, connect them just like how you would connect them in a satellite, and then try to run some simulations to see how it's working. As soon as everything works right, then you just stack them up inside the compact structure, and then you might do a few other tests. But initially, a flat start is just an easy way to debug and troubleshoot anything during um, your test. Also, one thing I wanted to note, just to clarify here, is you can see the white lines here, right? These are the wires that attach or interface with all the subsystems. And this is very, very like, important. There has to be like a whole team that needs to study how to wire these components, like how to cram them together, because these are very important in the sense that since small satellites are really small, right? If you don't really analyze or study how you're going to connect all these wires well, right? If you end up cramping all the wires and things get tangled inside them, there are so many wires that connect to a system, and if one thing removes, it's going to take you like weeks to figure it out. And so it's all. I can't hear you, Daniel. I see. So, Jemima,
Ah,
can you?
yes, I can actually hear you. It looks like it's an internet problem, so you may leave and join back,
Okay,
and it will fix
I just came
itself.
to in case.
Sorry about that.
Okay. Yeah, so yeah, that's about the flat sats. So the reason why we're able to actually have these smaller satellites is because of the advancements in electronic components. Right now, we have smaller transistors, components, microcontrollers are getting even tinier. So essentially, you can do anything that big satellite does in a small, because now those same ICs that used to be really big are now really small. So it's just that literally the same thing, but now it can fit into a smaller uh, compartment. I think that this photo also shows a different set of flat sats. So you can see the board stacked on the table and they're harnessed through the wires, and you have the solar panels attached on the walls. So it's just another indication of when you are testing satellite systems. Now, so as we all know, right? So we saw in the previous photos of how the unicorn and pocket cube was taking photos of the Earth. Essentially, small satellites can be used for Earth observation. So we can take images of the Earth for environmental monitoring. We can have like a hyperspectral cameras. Now, as I said, things are getting smaller. So cameras that used to be huge and big, they are now really small. So hyperspectral cameras are cameras that, based on wavelengths and frequencies, you can determine. They give some colors, right? And those colors have meaning. So with those small cameras, you can literally just fit it into a pocket cube easily launches into space, into low Earth orbit, and then you can do some analysis on the Earth, like based on the colors you are seeing. You can maybe detect like methane gas, or which like areas of the Earth are producing more carbon dioxide or things like that, and you can and all those things are needed by scientists and also people on ground. The same Earth observation also helps in precision agriculture and also climate change tracking, as they all correlate together with the smaller cameras that can fit on a pocket keyboard, or in general small satellites. So here we have some examples that Xavier-based solutions has actually done using satellites. So currently on the right image here, it's a lake in Kenya. I don't know if we have some Kenyans in the meeting, but yeah, there's a lake over here in Kenya, and essentially this image was generated and processed by Xavier-based solutions from Sentinel-2 satellite. So that's actually a it's actually a bigger satellite, but with small satellites, it can also do the same thing, but just I think it's something that is for the future. Like people are still working on that, but it is possible. So this is just showing the application of what is going to happen. So in case now we have this small camera that fits into a smaller satellite, while it's orbiting the Earth, you can just pick data from it and process it, and you can have a clear high resolution image of whatever part of the Earth you're looking at. You can even see clouds over here as well. Um, but something that maybe you guys might be familiar with is the image here, which was processed by Xavier Space Solution as well, and it was for monitoring deforestation in Crocosea Forest Preserve. So there's a whole paper on that. If you're interested, we can share that if you'd like to read about it. So we're trying to look at areas in Ghana that had a lot of deforestation activities. So you can tell between the green and then the light green, like green might show more trees and light green might show less trees, or even white spots shows like mining and things like that. So you can be able to, inform authorities and things like that. In terms of precision agriculture, you can also look at farmlands, right? On the image here shows a farmland taken from the satellite, and also it depends on whatever you want to do. Like if you want to check growth or water levels in the satellite, as I said, hyperspectral cameras are able to detect in different wavelengths, and based on that, you can have some color indications, and that gives you meaning. From that, when you do that, you have to confirm what you should see. So on the right, it shows the actual farm. So this farm is in Serbia, in Novi Sad, the capital of Serbia, I think. And essentially, what we did was we processed the image on the satellite, and then we know that this is what is happening on the farm, and then we now go to the farm, and I think this was taken by Lazar. He's our um he's I think he works on the thermal aspects of the team, and he actually went to the farm to take a photo to compare with the satellite data he processed from the bigger satellites in space. So these are some of the applications and real world applications, and we have used them, and we know it works. Further applications in terms of communication, I'm sure most of you guys have heard of Starlink. So I mean, Elon Musk is sending lots of smaller satellites across the globe to form like a constellation, or more like a net of satellites around. So you can always download and uplink your information no matter where you are on the earth. And this is essentially with miniature satellites, right? If you need connectivity somewhere, you can always launch a constellation of these smaller pocket cubes, keeping in mind of like the orbiting too, because someone might say, why are we just like launching so many of these things? But I think we'll come into that as we discuss that these things have been thought of, and we do our best to prevent, crashing of spacecrafts, and also preventing space junk in the atmosphere as well. Further applications is scientific research and exploration. These miniature satellites can have like payloads that can do some monitoring or measurements for scientific research, such as space weather, like monitoring the ionosphere, astrophysical observations, and deep space exploration. Like I'm sure you guys have heard of the James Webb Telescope. Now, here, if you have like photos of deep space, and we can study more of the galaxies. That's the same with small satellites, right? Small satellites can be able to achieve this as well with smaller components that may achieve similar resolution and can be enough for scientists to use as well, and also educational payloads. I know now. I'm sure in Africa, I think in Kenya they started doing. I read about it. They started doing some QSAT program. So small spotlights give student teams hands-on experience in the sense that they can make a payload and then okay, they want to test how can this work in space, right? Then because it's really small and it's cheaper, you can easily launch that into space and test your payload. Another example is here in Canada, there's a university called University of Alberta, and the students have made like a small magnetometer device that's supposed to spring out from the small satellites, and they're able to actually test in space because they're working with small satellites and it's easy to launch and it's cheaper. So it gives that kind of um, further exploration into scientific research from mega scientists to even university teams. These satellites, so as we said, right, they need to go into space, and one way this is cheaper now is because of ride share. So in the past, what used to happen is that because we used to have like huge satellites, right? The huge satellite will have to like rent the whole rocket, and that costs like more than a million, like more than $50 million, right? But now because it's really small, there's no point in sending one small thing to space like that. Now you can just ride share like a bus, like or maybe like a trotro. You just preserve your space, and then you can, based on your size and mass, they give you a document that shows you, okay, if since you are building to this capacity, this is the space we have for you. Design your spacecraft to meet these requirements, and we can take you to space. And tomorrow in our card session, we'll have a hands-on experience on like the Pocket Cube. I'll show you a document similar to that, and then if you can design a chassis or like a structure, that essentially when you have that, it's literally it is possible to send that to space because it would fit into uh the rocket, like I don't know, box or parameters, right? We'll talk about that tomorrow as well. So yeah, so right Aaron has made launching small satellites to space really affordable. um Also, here we're talking about launch and deployment strategies. So like this is a continuation from launching satellites to space. Some of the ways that they also launch is when the so basically the rocket sends the spacecraft into space, and these capsules, like from the rocket, they dock on the ISS, which Solomon spoke about, the International Space Stations. From there, the astronauts can actually take your small satellites and then put them into this on orbit deployer system, and that's what springs out the satellites. Or sometimes maybe you have a payload there that maybe the astronaut has to make some modifications to, maybe to run like a test before deployment. So all these things are ways of of how satellites are deployed into space. It's either they are directly deployed from the rocket, or they are sent to the ISS, and then astronauts deploy them into space. So as I spoke about before, we are launching all these small satellites, and but what about space junk? We are sending a lot into space, and we need to monitor our space debris. So this image here is a clear photo of space junk or space debris that's just floating in space. It's just uncontrollable. All that humans can do is just predict its trajectory and know where it will hit Earth, but we can't really control it, right? So one way that we are trying to prevent this is the United Nations Office for Outer Space Affairs, that I think in short, UNOSA, has made some regulatory policies such that engineers like us that want to launch satellites into space, we have to follow some regulations. And the first one is the 5 year deorbit rule, and then the 25-year deorbit rule, depending on the size of the spacecraft and the mission. So they just try to ensure that no matter what, if you're launching a small satellite, make sure that after you finish your mission or whatever, it's able to deploy. Sorry, like I mean the orbit within 5 years, so that it will prevent having space junk in the in on like on the like in the orbit by crashing with different satellites. Because when they crash, right, they can scatter into so many pieces, and then you even create like billions of more space junk. So it's very important that we follow this regulation. And that's in this example here is showing some of the analysis that can be done to ensure that your spacecraft is able to orbit. So for instance, the Pocket Cube Solomon was showing you, we did an analysis based on a software called Drama, and basically um, you have to take the surface area of each side of your Pocket Cube. So in general, just to understand what's happening here, the, the only how this is deorbiting, right? So you can see the line here. It's launched in 2026, and then it's slowly dropping to Earth. And here shows the altitude, and then the x-axis shows the years, and then the y-axis shows the altitude. So how the orbit is through natural drag. So even though space is a vacuum, there are still particles of air in space, right? Or let me say molecules that still interact with the spacecraft, and that's what slows it down. So we did an analysis that okay, if we launch in 2026 and we have a mission lifetime of 2 years, so that's so 2026 to 2027 and 2027 to 2028. 1, 2, 3, 4, 5. So it means that our mission will end in 2028. Like that's our total mission lifetime. Again, showing that 5 years from then, that's 1, 2, 3, 4, 5. It will deorbit in 2031. And that's 5 years from then. So with this analysis, when you go into the rocket, you have to pay for you have to essentially launch with the rockets that will be deploying satellites at around this altitude. So you know that okay, I can deploy this altitude and then I can be able to deorbit within the 5 year deorbit time, and then space. I mean, save the atmosphere from further space junk. Put this for so here industry and commercial opportunities. So as in the past we had bigger satellites, now the smaller ones. So it's just showing the trend. Since now smaller satellites are way easier to build and launch, right? And it's accessible to almost anyone on the planet. It's increasing as the year goes by. So we have more of the mini satellites being producing green rice. We can see those enlarging, and that's what's going to happen in the near future. You're going to have less of bigger satellites and more of smaller satellites doing basically the same thing, faster and probably better as well. Future trends for small satellites. So these small satellites, in, in the future, we are seeing that already companies are making systems to uh, to service a satellite in space. So the first one here is the on-orbit servicing and assembly. So some of the companies that I've seen that are trying to leverage on small satellite technology is to be able to send a spacecraft that has like maybe like a robotic arm to service other satellites in space. Because sometimes these satellites they can be like a minor issue and they don't really need to deorbit, but maybe like a minor fix can fix them and then they can last longer in space. So these are some of the things that are that we are looking forward to in the future, and also intersatellites communications and constellations, launching more of these smaller ones to improve the connectivity around the world, especially in the polar orbits. I mean, sorry, in the polar regions of the Earth, the North and South Pole. If you like, you can go online and search for a map of the Starlink satellites. You would see that there's a cluster of them around the globe, right? There's a cluster, but there's literally none in the polar region. So these are some of the ways that in the future we are hoping that these constellations can be used in the polar like regions as well to improve communications and in general AI. AI is now everywhere, so expecting that AI will be integrated into small satellites, and then we can have a lot of automations in space and whatsoever. Um, Shaping the future of space together, opportunities for collaboration and partnership. So small satellites, though is accessible, right? It's not just for engineers, right? Because what happens now is that almost everyone gets to be involved into a satellite program or a satellite system, right? So I have an example of this. Currently at my university, we are making a small satellite. So as I said, for the was the CubeSat, right, with measures 10 by 10 by 10, and we are making like three of those stacked on top of each other. One thing that shows opportunities and collaboration is that we have the indigenous communities which live in northern Canada, and they hardly have access to technology and stuff. But one way we are, but one way, but now it's because of small satellite, they are now involved because satellite we are building is supposed to go into space and measure sea ice in their communities, right? And the only way you can build such a payload or a system like that is to communicate with those that live in that kind of area or ecosystem, right? They were born there, and they were raised there. They hands they travel through like the ice, so they know every aspect of the ice, right? So they come along into the project and then they show us differences between good and bad ice, and then scientists in different schools can also have access to that data for further research. So it's mostly about so small satellites bring cool development, right? It's not so engineers can't do it like alone, right? They need um different parts of people from across the world, whether you're an artist or you're into politics or whatever you are. There's always some way of collaboration and partnerships in small satellites, and this collaboration is going to improve research and development because now more people are getting involved, so there's more results and better understanding of how things are going, and this also supports education and outreach. For instance, I think we have some concept modules. I don't know if it was shown in the previous photos. We have some concept modules. Basically, also a satellite, but this time it fits into a can, like a Coca-Cola can. So, and we use that for space outreach. It has a power board. It has some GPS. You can send signals to a flight on a balloon. So all these things, support education and outreach. Thank you. Let's see if you have any questions from here. And I can bounce.
Right.
First one.
That was
Yeah.
brilliant. Yeah.
Yes.
Jemima, go on, sorry.
Oh, sorry. All right. Thank you, Daniel. That was great. Thank you for taking us through all of these amazing technologies. Everybody's excited. Yay. So we want to ask a few questions in the platform. So Daniel, do you want me to read it for you or you want to read it yourself?
I think I can read it. So
All
Terry
right.
is saying, what is an OBC? What is its function in the Pocket Cube? What kind of software do you use to run simulations? So when the rocket components detach, they do not fall immediately down to Earth. So first of all, an OBC in full is called onboard computer, and it's basically the brain of the computer. So for instance, if you've done some Arduino projects, your Arduino microcontroller is like your OBC. It has all the codes and sends commands to your camera or to the power board. Okay, I need power here, things like that. And the function in the Pocket Cubes is basically to operate in general what you want to do. So for instance, if you want to take a photo of the Earth, the OBC is what's going to tell the camera that that okay now based on the GPS location or GNSS, we are at the point we want to take. So please, like camera, switch on and take a photo, and then they always will send it to comms and comms to downlink it to like the earth. So it's more of like the controller of the pocket cube. Software used to run simulations. So there are different kinds of simulations. You can use MATLAB as well to run like orbit a- analysis. You can use a software called STK, which is also like an orbit simulation software. Also, we have things like in general programming. You can just run some simulations on your Python software or your GitHub. So when Rocket's components detach, they do not fall immediately down to Earth. No, so I think first what someone was saying the last time was so when it passes the common filter, right? There's vacuum, right? So it just floats into space, right? But the part that it detaches before it crosses the common filter. So when it detaches, the second capsule also has a small thruster module on it, and that propels it outside the common filter, and then the other and I think the rest of it actually lands on it. If you look at SpaceX, their YouTube videos, they have like things called the boosters, also sends the rocket into space, and they actually are able to come back to Earth and land safely. Yeah.
Yeah, maybe. So I think that was the question when you were presenting. So I'm fascinated how mini satellite is relatively the biggest, but has the name mini.
Yeah, I think it's coming from where is it? Here. Hey, boss. I was talking about this here, mini satellite, and it's the biggest. So I think so. This is small satellite by mass, right? So it's not actually the bigger ones. The conventional ones we're talking about, the weight tons. They are not 500 kilograms. Like they were like from over 1,000 kgs. So this is just showing that okay, when they started shrinking these satellites, because you need to start small. Because I think back then we didn't have those small IC. So instead of having the one that was weighing like a ton, they started with mini satellites, and that was 100 to 500, and then micro, nano equals. So it's not really seen that like so. It's not like the like conventional ones are the mini. They're actually larger or heavier than this. Yeah, this is like just showing the trend of the beginning of smaller satellites. Yeah, I think I didn't clarify that. Thanks for that. Can you use Python programming to configure commands for the OBJ? Of course, you can use anything. C programming. You can use yeah, any programming language you can think of. Java, Django, anything. So it all depends on what you want to achieve and your expertise, right? Yeah. So anything works. Yeah. Do you have any more questions? Because I need to run. I
Okay.
need to-
I think if there are any more questions, if you think of something, you can just send us an email. Our website is going to put it in the chat. Then we have our social media platforms up top. Then social media platforms, everything. Let me just post them here again so that we can see and you can come into contact with us. Okay, yes. So yes, I think we have do we have any other session? Like any
Yes.
question and answers? Yes, good.
Yes. So if there are no more questions, so Daniel,
Oh,
before you
there's
go, I
one
think
more.
there's one more question. Yeah. So how are CubeSats, I guess, manufactured? CNC machining, 3D printing?
Yeah, that's a good question. So I think all of the above, but of course, if you want to send it into space, if you're not going to 3D print it because something called outgassing. 3D print is more plastic, so in space it would turn into I mean, like because of vacuum, so it releases some kind of particles from the plastic, and then They can, you know, go over components of cameras. So CNC machine is the closest yet. If you buy, if you make your card model, you send a drawing to the machine shop, and they can, based on the drawing, they buy like an aluminum stock or whatever material you want to use, and you can just CNC it and make your parts ready. Can you please share the PowerPoint? Definitely. Solomon or Jemima will share it by email or something if you like.
Yeah, so when the email is being shared, we will add all of these resources and the links and everything. So yeah,
Okay,
thank you.
great. Yeah, so thanks. Also, how affordable could the pocket cubes would they be intended for individual use or primary for organizations? Uh, Daniel?
Yeah, so Priscilla, so the pocket cubes, I mean, we have built one already. Is really cheap. Like I think that the one we built was like in total, I would say like in CDs like maybe 500 to like 1,000 CDs
Oh, you
thereabouts.
mean maybe the concept?
Yeah, the concept, yeah. But I think the pocket cubes, I'm not sure what Solomon, like what's the range
Yeah,
for the
yeah.
price?
So, yeah, the Pocket Cube, it's a bit much more expensive than this, and um, the reason why it is because you use space grade components, and these are very expensive components to put on Pocket Cubes. Um, these days, people sell Pocket Cubes around 25K, but this depends. 25K, I mean $25,000, but it depends on what you're using a Pocket Cube for. So for example, if it's just a mission that has a camera on it and you have to put a space grade camera, the price could go really up. Or if it's a pocket cube that's going to do something very basic, it just has some temperature or pressure sensors on it, it could come very low, right? Maybe a couple of thousands of dollars, but yeah, it's cheap compared to how much a CubeSat is worth, which is usually around millions of dollars to build and also send into space. But yeah, that's sort of the price margin. In terms of whether for individuals, I mean, if you have a 25K dollar somewhere and you want to buy a satellite for yourself, I think it's good that people can do that now. But yeah, individuals do this depending on what you want to use it for. You could buy and do whatever you want to do. Really. But yeah, good question, Priscilla.
Yeah, yeah. I also think the price also depends on if it's space ready. Like if let's say they have tested it to with maybe like vibration, because there are a lot of tests you need to run. And I think tomorrow I guess speaker will talk about all those kinds of things. When they have vibrated it and like they've tested that okay, it's fitting up, when they've done like analysis, they increase the price because it's literally it's you know like it's ready to launch. So
Mhm.
that the price as well. Yeah. Good question.
Thanks for the questions and thank you, Daniel, for that interesting presentation. So we just have one more section to go. It's not a long one. It should take like 10 or 5 minutes really to finish. It's just one aspect of satellites and yeah, let me stop talking and already start talking.
All right. So as we're waiting for Solomon to start sharing his screen, don't forget if you have any questions, put them in the chats. Follow us. Check out our website, LinkedIn, everywhere. Yes. So Solomon is done. Let's have a good session.
So yeah, so Daniel, well, I have done a little bit of introduction into what space and satellite technology in general is and some of the few things you need to know. And Daniel also spoke about specifically small satellites, the different types, and what you could use those different satellites for. Now I'll talk about a very important bit of satellite or having space technology in general, and it's something called ground stations and satellite networks. This is very important because without these things, you can't actually operate satellites or do anything with them. So in terms of satellite networks, Daniel has hinted to these things already. So when we have a lot of these satellites in space and they talk to each other, we call them satellite networks. They are very, very important because they are useful in the way we communicate, the way we send signals across the globe and do different things. And it's a very, very useful thing related to satellites in general. A very good example, which we have talked about over and over again, is Starlink. So it's not just one satellite, you have a lot of these satellites working together. And sometimes you can actually see this in the night sky. So this is an actual image that was taken um, of the night sky. And the way these satellite networks work, so they are all deployed in some form of pattern. So you will see like a streak of light in the night sky like that if you happen to be an area where there's less light pollution. And those would be the Starlink satellite networks, and they will be just a streak of light, exactly like what you see here in the sky. And they provide continuous coverage of especially internet, because it means you can always send signal and it bounces off the satellite and you can get it back. The reason why, more of sort of explaining why sometimes we don't get network, is if there's no satellite to send your signal you're sending to, I mean, usually what will happen is, so the signal travels from your phone, goes to a tower, and from the tower is boosted to go to a satellite, and then the satellite can send it to wherever you want to. So, for example, if I want to talk to Ghana, signal from my phone goes to tower, tower to satellite, and goes to a ground station in Ghana, and then goes to the person's phone. So, if there's no satellite that can carry that information, that means there is no network coverage. But with these satellite networks, it means there's a lot of these satellites everywhere all the time. So there's always a satellite to be able to send your signal around, which is what makes it very useful having these satellite networks. We've already talked about a few examples. We have Starlink, we have OneWeb, and they have thousands of these satellites for global internet. Another important bit is the ground station, as I've just mentioned. So the ground stations are very important because they receive information from the satellite in space. So we usually call it telemetry. So the telemetry would be the information from the satellite about the satellite speed, the kind of information it's transmitting, what frequency range this satellite is transmitting at, what is the altitude of this satellite. And these are all very, very important information that we need to get from these satellites to be able to know how to operate them, to know whether they are functional and not or not. And it also gives us a good link between space and then Earth, because we can communicate with these satellites in space, get information, which will be very, very important, even telling us what kind of information. Maybe to give a very crazy example would be to say, I mean, if we would ever receive any signal from, say, an extraterrestrial life, if there's ever anything like that, our ground stations will be the things that will receive those signals. So in terms of even the bigger picture, ground stations are very important. I've already said that these ground stations are very, very important because we receive information about the satellites that are in space. But another thing we can also do is, remember, when we send these satellites into space, right? We would put specific information on what these satellites should do. Let's say there will be a button here that I can push that can turn this pocket cube on. But in space, I can't go and push that button, right? You need to be able to talk to this satellite without having to go to space. And one way we can actually do that is by using this ground station. So because our ground station is linked to the satellite, we can send instructions to the satellite and tell you, oh, we want the satellite, we want you to turn on, we want you to flip, we want you to emit a signal to us or something. And those are all things that the ground stations helps us to be able to do. And of course, we have talked about the fact that so it does two things. It can send signal to it, and we can also receive signal. So signals from satellites can be weather images, communication signals. It can even be scientific data on specific things we want to do, and we can use this ground station for all that. One very, very simple thing, I think tomorrow I'll try and demonstrate that this, if we have time, how you can actually, a software that you can use to track satellites. And these are also softwares that are related to ground stations that keep looking in the sky and picking signals from satellites, and I'll talk about how you can even build something like that. I think in the, well, not the complete one, but show you how this can be done. You can actually build a very simple ground station called the RTL SDR satellite tracking ground station. SDR is for software defined radio, and what it is it's a simple component that probably I think tomorrow I'll show you an example of that. And what you could do is with just this simple thing and with some simple hardware. So this here is just a simple antenna. We are just using something like almost a TV dish, really. I said TV dish, a TV antenna, um, and some metal rods. And what you can do is you can use this together with some other different components to be able to receive signals from satellites. And these signals, you can even process them into an image. So this is something we did a few months ago in South Africa, in Ivory Coast, where a team from X-Space want to build a ground station, as you can see in the background, that they can use to receive signals from one of NASA's satellites, weather satellites. And in this case, you can see there's an image of, if you can just see the image in the black and white where I'm showing the cursor. It's an image showing some part of the United States, and you can see some clouds and some areas there. And can build a simple ground station to be able to do that, which is a demonstration of the usefulness of ground station, like I said a few minutes ago. And you can visualize that in some software, which again, if you have time tomorrow, I'll show you how all this comes together. So that should be it in terms of just covering the basics of what a ground station is and how it's related to satellites. Thank you so much for listening. And if there's any questions, please do ask now.
Great. This was awesome. This was awesome. During the presentation, Hadassah just said that I've seen that before. I think it was related to the slide with the ground
Yes,
station.
yes.
Yes, so yeah, she has seen that before. Yes, sir. If there are any more questions, any contributions, anything you want to ask or be a part of, please let us know in the chat so that we can attend to you.
So maybe whilst we wait for questions, I'll just talk about, so in terms of X-Space in general, what we do. So apart from this SheSat campaign where we will teach people about, about specific things about space. So we had sections where we did professional and personal training. This is the satellite training. We will have another training on the electronics, and we'll have another training on building concepts and things like that. So if you please make sure you follow us on I think we are very, very active on LinkedIn, on Instagram. You can find us at Xavier Space Solutions or X Space Solutions, and also on Facebook. If you want to send me an email, you can use this. And I think we also do have a WhatsApp channel that you can join where we put information about different things. I think there will be times where we would invite people to probably do internships and things like that. Or people who want to collaborate with us on things that we are doing, please reach out to see all those things or get those information. Yeah, so Jemima has shared a link to that. And also for SheSat also has a LinkedIn page, so please make sure you follow so that more people can know about this and also learn as you have also been learning. I think there's a question. Is Xavier Space Solution open for collaborations and projects, partnership with student clubs in Nigeria? Of course, we're happy to collaborate on especially student project because I think as you could, if you were here at the beginning, we are a group of young team. So we pretty much understand young people wanting to be in space, and we would, of course, be happy to support all that. So yes, we'll be happy to do that.
Priscilla asked a question before that. She said, please explain the telemetry again.
So telemetry is basically information from satellites. So when people in space or engineering say telemetry, they just mean information that you can get from a specific instrument, and usually it's a space instrument. So maybe a satellite. Telemetry would be things like the temperature of the will be information of that satellite or information regarding the satellite. So in this case, it can be the temperature, the power, the what kind of altitude is the satellite. Those are all telemetry, and these are information that usually are sent to the ground station. Or if we want to even make changes to those parameters, we can actually do that. So that's just a little bit. Again, maybe tomorrow I can show you an image of the software we made to control the experimental satellite, and you can see the telemetry bit, which has all those different informations too.
Okay, great. So while we wait for more questions, let's just take a group photo. Let's take a group
Yeah, I
photo.
think
Yes.
a few people have
Yes.
even already left, but yeah, if you don't
Ah,
mind turning on your camera, we could take a group photo and I can stop. So,
yes. Oh, yes, that would be lovely. So let's just put our videos on. We are very lovely, beautiful people. We want to see your faces.
yeah,
Yes.
and whilst we do that, I think people wanted to see what the pocket cube looks like. So this is how it is. And if you want to compare to a Rubik's cube, you can see it's almost the same size here. But yeah, we have images of this on our website, so you can actually browse and see that. And like I said, Daniel tomorrow will also be teaching you guys how to make one of those plates for it. I think you will see more images. But yeah,
Yeah, let's just turn our photo videos on. Um, just, just okay. So okay, I guess we're ready. Everybody, big smiles. Want to see all our teeth? Big smiles. Okay. Yeah, another one. Just one more. One more. One more. Yes, lovely. Yay.
all right,
Thank you very much. Yes, let's go on with the session.
all right. So yeah, I think tomorrow same time. Yeah, and yeah, there will be a hands-on section, so you guys will actually get to. We want to make sure that people can actually build something. So tomorrow there will be a section where you guys will be able to build some part of a satellite, which I think is pretty cool. Hopefully we can have more time. I think going on in the campaign where we'll be able to spend some more time. I think actually at the end of the SheSat campaign, people would actually be um, building a CubeSat. I said a CubeSat, sorry. Uh, should be a concept, and then yeah, people should be able to learn, or at least you have some form of skills actually over there. But yeah, all right, cool. Do we have any announcement, Jemima?
So for the announcement, thank you all for joining this session. The WhatsApp group has been put in the chats below, so just join the WhatsApp group. Follow us on all our social media platforms. There would be certificates issued for joining the two modules. So I'm glad you. Let's make sure to join tomorrow's on. And yes, for they'll need to bring their laptops for the hands-on session, right?
Tomorrow, yes, yes, we need laptops. Yeah,
Yes, exactly. So just bring your
yeah. So
laptops for them.
yeah, it wouldn't work on a tablet or phone. What we want to do tomorrow, we want to do serious stuff. So.
Yes, exactly. You want to be serious. So let's get our laptops ready. If you don't have, don't worry, you can follow us. Everything will be recorded. So if so when you get a laptop, maybe at school or somewhere else, you can come back to the session and practice on your own after this module is over. So no worries about that. We will post all the SheSat Ghana programs on our YouTube channel. So by the end of this year to get everything together. So just keep following us, keep looking towards us. And yeah, you have a great time. As Solomon said, there'll be time for internships if you want to learn more, to join the team. So Just be active, contact us, and yes, you will be all right. Yes. Any final words, Solomon?
No, I'll just say thank you so much for joining, and hopefully this was great. And yeah, see you all tomorrow.
Yes, see you all tomorrow. Goodbye. Have a good day, everyone. Bye. You also get some emojis action in. Feeling left out. Yes. Okay. Yes. Awesome.
Have you stopped recording now?
I have